Role of entropy in machine learning solutions is AML 19766. The topics present in this slideshow are introduction to entropy in machine learning, what is entropy in machine learning, mathematical formula for entropy, what is a decision tree in machine learning, use of entropy in decision tree, what is information key in entropy, how to build decision trees using information gain, advantages to the decision tree, introduction to the entropy in machine learning. We are living in technology world and somewhere everything is related to technology. Machine learning is also popular technology in the computer science world. The computer to learn automatically from the experiences. From the experiences. Okay. Uh, Machine learning contains lot of algorithms and concepts that solve complex problems easily, and one of them is entropy in machine learning. Almost everyone must have heard the entropy word once during their school or holidays in physical and chemistry. The base of entropy comes from physics, where it is defined as the measurement of disorder, randomness, or impurity in the system. In this article, we will discuss what entropy is in machine learning and why entropy is needed in machine learning. So let's start with a quick in the introduction to the entropy in machine learning. The entropy is defined as the randomness or measuring randomness or measuring measuring the disorder of the information being processed being processed in machine learning. Further, in other words, we can say the entropy is the machine learning metric that measures the unpredictability or impurity in the system. When information is processed in the system, then every piece of information has specific value to make to make to make and can be used to draw conclusions from it. Conclusions from it. So if it is easy to draw a valuable conclusion from a piece of information, then entropy will be lower than machine learning. Or if entropy is higher, then it will be difficult to draw any conclusion from that piece of information. Entropy is a useful tool in the machine learning to understand various concepts such as future feature selection, building discussion trees, and fitting classification models, etc. Being a machine learning engineer and a professional data scientist, you must have in-depth knowledge of entropy. in machine learning. This is very pure, this is less impure, this is very impure, minimum impurity. What is entropy in machine learning? Entropy is the measurement of order or impurities in the information processed processed in machine learning. It determines how a decision tree uses to split data. We can understand the term entropy with any simple example. Flipping a coin. When we flip a coin, then there can be outcomes. However, it is difficult to conclude what would be the exact outcome while flipping a coin based. There is no direct relation between flipping a coin and its outcomes. There is a 50% probability of both outcomes. Then, in such scenarios, entropy would be high. This is essence of entropy in machine learning. This is low entropy. This is high entropy. Consider a data set having a total number of n classes. Then the entropy E can be determined with formula below. This is the mathematical formula for entropy, where P1 is equal to probability of randomly selecting an element in class 1. Entropy always less between 0 and 1. However, number, depending upon the number of data, it can be greater than 1. But this high value of let's understand it with an example where we have a data set having three colors of fruits as red, green, yellow. Suppose we have two red, two green, and four yellow observations throughout the data set. Then, as per the above equation, E is equal to minus PR log 2 PR plus PP log 2 PP plus P1 log 2 E1, where PR is equal to probability of choosing red fruits, PG is equal to probability of choosing green fruits, and PY is equal to probability of choosing yellow fruits. PR is equal to 2 by 8 is equal to 1 by 8, as only 2 out of 8 datasets representing red fruits. PG is equal to 2 by 8, 1 by 4, as only 2 out of 8 data sets represents green fruits. Py is equal to 4 by 8 is equal to 1 by 2, only as only 4 out of 8 databases represents yellow fruits. Now our final equation will be such as now our final this equation will be such as no entropy will be 1.5. E is equal to E is equal to 1 by 4 log 2 of 1 by 4 plus 1 by 4 log 1 by 4 plus 1 by 2 log 1 by 2 is equal to 1 by 4 minus 2 plus 1 by 4 minus 2 is equal to minus 1 by 2 minus 1 by 2 minus 1 by 2 is equal to minus of minus 1.5 is equal to 1 point. Let us let us consider let us consider a case when all observations belong belong to the same class same class, then entropy will always be zero. E is equal to minus 1 by E is equal to 1 minus 1 log 21 is equal to 0. Then when entropy uh, becomes 0, when entropy becomes 0, then the darkest has no impurity. Data sets with zero impurities are not useful for learning further. If the entropy is 1, then this kind of data set is good for learning. For the x-axis, we have 0.0, 0.2, 0.4, 0.6, 0.8, 1.0. 0.2, 0.4, 0.6, 0.8, 1.0. This is entropy. What is a decision tree in machine learning? A decision tree is defined as the supervised learning algorithm used for classification as well as regression problems. However, it is primarily used for solving classification problems. Its structure is similar to a tree where internal nodes represent the features of the dataset, dataset and the branches of the tree represents the decision root and the leaf nodes as an outcome. Decision trees are used to predict an outcome based on historical data. The decision tree works on the sequence of if then else statements and root, which is our initial problem to solve. Decision node, root node, decision node, leaf node, leaf node, leaf node, decision node, and decision node to leaf node. Leaf node is defined as the output of decision nodes, but if they do not contain any branch, it means the tree contains the situated further from this node. Root node, as the name suggests, a root node is the origin point of any decision tree. It contains the entire dataset, which gets divided further into two or more subsets. The node includes multiple branches and is used to maintain the decision in classification problems. Splitting it is process that divides the root node into multiple subnodes under some defined conditions. The next one is branches. Branches are formed by splitting the root node or decision nodes. Parent node. The node or the root node in a decision tree is called the parent node, the child node. Except for the root node, all other nodes are called child nodes in the decision tree. Use of entropy in decision tree. In decision tree, heterogeneity in the leaf node can be reduced by using the cost function. At the root level, the entropy of the largest column can be determined by the Shannon formula, in which Mr. Shannon has described the weighted entropy as the entropy calculated for the targeted column at every branch. However, in simple words, we can understand the weighted entropy as the individual weight of each attribute. Further, weights are considered as the probability of each class individually. The more the decrease in entropy, the more information is gained. Low information gain entropy. High information gain low entropy. What is the information gain in entropy? Information gain is defined as the pattern observed in the dataset and the reduction in the entropy. Mathematically, information gain can be expressed with the below formula. Information gain and entropy of parent node minus entropy of child node. In one column, entropy, and in another column, uh, information gain. In one row, scenario 1, scenario 2, scenario 3. In scenario 1, 0.78123450, 0.2187655, 01 bronze 0. Let's say we have a tree with a total of 4 values at the root node that is split into the first level having one value in one branch. Now to compute the entropy at the child node 1, the weights are taken as per branch 1 and branch 2 are calculated using the Shannon's entropy formula as we had seen above. The entropy for child node 2 is 0 because there is only value in that child node's meanings. How to build a decision trees using the information gain. After understanding the concept of information gain and entropy individual node, we can easily build a decision tree. See the steps build a decision tree using the information gain. An attribute with the highest information gain from a set should be selected as a parent node. From the information below, it is attributed A. The second point is left child nodes for every value of attribute 2. Advantages of decision tree. A decision tree can be easily understandable as it follows the same process of human things while making any decision. It is used to solve any decision related problem in machine learning. It helps in finding out of all the possible outcomes for a problem. Thank you. The and